demo setup, at the bottom, the logical view, or what we are trying to show, is that a VM is talking to a storage node, and VM1 is actually, the traffic coming from the VM1 is encapsulated in VXLAN by the vSwitch in the hypervisor, and the storage server is still talking .1Q VLAN. And it's the storage node is on VLAN 160, and the hardware VTAPs or the VMs they belong to VXLAN segment or VNI. VNI stands for Virtual Network Identifier. That belongs to VNI 5000. So it essentially takes 3 steps to integrate NSX with CloudVision. The very first thing that you have to do is you have to enable, first of all, HSE on CloudVision. And the moment you enable the HSE, what you get is a certificate. Now this certificate needs to be ported into the NSX. This is a one-time porting or one-time configuration, but it's required for the authentication purposes. And obviously the HSE needs to point to the NSX controller, and that's what we are trying to do here. So here, once we have the certificate that we get out of the switch or a CloudVision, what we do is we go to the service definition. Hardware gateway act as yet another service from NSX perspective, and we try to add this gateway here. I give name, let's say my HSE. I put the certificate that I get from by enabling the HSE process on the switch or CloudVision, and basically that's the end of registering a gateway node to NSX controller. There's a few important aspects here. One is you see there's something called BFD which is enabled. It's an important aspect. There is, and I have a slide on that, there is something called replication node that NSX has for handling the bump traffic or the broadcast unknown unicast or multicast traffic. That's the multi-destination traffic. And what NSX does is, in order to check the liveliness between the hardware gateway and those replication node, there is a BFD that runs on the VXLAN tunnel. So from NSX perspective, it's a mandatory feature to have. There's a limit on how many replication nodes you can have, but it's important that your switch supports BFD and has a decent scale and does not put a toll on the performance of switch. Now the second thing is, once you have your hardware gateway registered, you need to go and attach that hardware gateway or a port of that hardware gateway to your logical switch. In NSX world, every virtualized network is called logical switch. So all the VMs are automatically belonging to a segment, are automatically part of the logical switch. On the hardware side, what you have to go do is add the hardware attached port. So let's say that the segment that I focus on is database segment, which is the segment ID 5000. And what I do is I add the port here. By default, my gateway or HSC actually comes up, but if you have multiple HSCs, you can actually select from the drop-down menu. And there are three things that you give here. One is the switch name. Because the HSC can front-end multiple switch, you can specify which switch in that cluster that you want to attach, the port number, and the VLAN, because you need to tell from NSX to that switch what is the mapping between the VXLAN to VLAN. And that's pretty much it. That's how you attach your hardware port to NSX. Okay, so a quick note about the replication service node, right? There is a little bit of a detail how a multi-destination traffic actually works when you have a hardware gateway attached or a workload sitting behind a hardware gateway. So at any given instance, there is basically a control plane based sharing of the state. At any given point, CloudVision should share the state of the VXLAN or the mapping between of the segments between NSX, but there would be occasions where you might have unknown unicast traffic. And for those reasons, what NSX does is we do not rely on multicast for the bump traffic flooding. what we do is, or what NSX does is, it actually randomly select some hypervisor as replication service node. And the idea here is that the replication service node are the ones you need to send the traffic, and they will actually do an ingress replication and send it to all other nodes in the segment. So hardware gateway does not do an ingress replication. It just sends one flow or one stream to the service node, and they do it. Obviously you don't want to rely on only single service node, and what you do is you can create multiple service nodes. Key thing to understand here is when a VM which is sitting on a hypervisor needs to send a bump traffic, it doesn't send the traffic to service node, because in NSX these service nodes you can consider as they are distributed across all hypervisors. So a traffic generating from the hypervisor will not hit service node. Only the traffic generating behind the gateway or hardware gateway will go to service node. So the questions around how am I going to scale if I have few service nodes is not an issue, because you can have quite a few service node and the only traffic it takes is hardware gateway. Yes, please.
Is there any special reason why you are not using multicast?
Yeah, so the primary reason, there is a mode in NSX where you can leverage multicast, but if you go and talk to customers, more and more customers want to have a simplified underlay, and multicast seems to be a protocol which is little complex to, and there's not enough expertise there. So from an underlay perspective, you want to have a very simplified underlay with a typical OSPF or a BGP protocol running. That's why. Well, so the node actually sits in the hypervisor. It knows from NSX controller at any given time what are the members or the VTABs that belong to that segment. So its job is to basically create the multiple number of streams, and each stream goes to one of the VTABs. So it's basically multiplying the number of flows and sending individual unicast stream to the VTABs, right? And this is the way you enable basically there will be available replication node. These are the IP address of the hypervisor. You just select, and in this case I've selected 2 nodes, and the replication cluster basically shows up at the bottom. With that actually so this was 3 steps. I have a recorded quick demo. This actually will run for probably 2-3 minutes, but this gives you a good idea of how to actually integrate CloudVision with NSX. So let's take a look at how I'm doing all these things in a shot. Here, the very first thing I'm trying to do is create those replication node, and I have a cluster of 2, and basically once I have the replication node, it shows up at the bottom, and that takes care of my bump traffic now. On the CloudVision, basically CloudVision uses the same EOS and the same CLI. All I'm trying to do is basically get into the CloudVision mode in EOS, enable the service HSC, and point this HSC to the NSX controller. Be aware that in HSC terminology it calls manager, but actually it's a NSX controller IP. It's not the NSX manager IP. And NSX, we these days use 6640 port number, so we have to specify that. At this point, HSC configuration is complete, and you are ready to actually glean the certificate from HSC. So show HSC certificate will give you the certificate. This is the certificate you copy, and basically paste when you add the hardware gateway. So let's say I put a name Arista. I can use any arbitrary name. Put the certificate here. It's a mandatory one-time thing that you have to do, and once you do it, your hardware gateway is enabled. BFD is automatically enabled by default here. And let's take a look. I have this ping working between a server and a VM, and I swear we have not mugged around. This is an actual recording. So I want to show you how quickly, the moment I attach the hardware port, pings will start working. So right now the pings are not working because the hardware port or hardware gateway is not attached to the logical switch. I go to this database segment, click on it, I say attach the hardware port, And essentially, my HSC shows up here, Arista. I click the port number, it'll show me the leftmost side says what are the switches that are catered by this. I go select the port 18 because I know the server is connected to port 18. And of course, I need to give VLAN 160 because that's the mapping between 5000 and 160. And the moment you hit OK, instantaneously the ping starts working. We have not cheated here. And the thing we cheated here is now when I detach the port, you don't want to wait for 30 seconds, so we have cut down the time. But essentially, the moment you detach the port, it takes the ping to time out, and obviously the pings are not working anymore. So this is how simple it is to attach the hardware gateway. There are multiple APIs to do it, so you can obviously script this process as well, and as and when your new segments are coming, you can essentially automate the hardware attachment seamlessly through the automation script. Yes, please.